take a look at how we would use our knowledge now to answer a question like this. When is our general sinusoid 9 plus 7 cosine of 2 pi divided by 13 times the quantity x minus 4 equal to 5? You can see I've graphed the sinusoid here and drawn a line at y equals 5. We're going to take three approaches. We're going to find answers graphically, numerically, and algebraically. Let's start with the graphical approach. For the graphical approach, we simply look at the graph and read our x values to an approximation where the two lines, or the line and the curve, intersect. So, the first time they intersect is right here. And we'd estimate that looks like about 4.5 negative. Then we see another intersection just to the left of the y-axis. Looks like about negative 0.5. Our next intersection here at about 8.5. Our next intersection out here looks like about 12.5. Our next intersection out here, looks like about 21.5. And finally, our last intersection that we can see looks like about 25.5. So there's our graphical approach to finding solutions. Our numerical approach requires the use of our graphing calculator. I've put the equation into y1, the sinusoid into y1, 9 plus 7 cosine 2 pi over 13 times x minus 4. In y2, I've put the line y equals 5. And if we look at the graph, here it is. So we want to find solutions, which means we want to find intersections. So I'm going to take the first two positive intersections, or the two intersections closest to the y-axis. So second, trace or calc, find an intersection. So I'm going to find this first positive intersection by going first just to the left of the intersection for my left bound, and just to the right of the intersection for my right bound, and my guess. And I get an initial solution of 8.508. So there we have the 8.508. Now I'm going to find the next positive solution or intersection. So I'll go back to my calc menu and find the intersection. And I'll move over closer to that second positive solution for my left bound, to the right side of the intersection on the other curve for my right bound, and my guess. And here my solution is 12.4915. So now I have these two solutions, 8.5084 and 12.4915. Now that I've found these first two solutions, I'm going to take advantage of the periodic nature of our sinusoid to help me find additional solutions. So the first thing I'm going to do is find the solution to the left of my initial solution that's exactly one period away. So I'm going to find this solution right here. So I'm going to go back into my menu second trace, ask for option 5, and move the cursor all the way back to that first solution that we see on the screen, to the left of the y-axis. So I need to be to the left of that. So there's good. And then I need to be to the right of the intersection. And hit enter again. And I get an answer of negative 4.4915. So my second solution is negative 4.4915. If I find the distance between those two values, 8.5084 and negative 4.4915, I find that distance to be 13 units. So if I subtracted 13 from my initial value, I would get this value, negative 4, which means that if I added 13 to my initial value, I'd get another intersection because of the periodic nature of my function. So a solution at 21.5084. I can take advantage of this knowledge and find the solutions for that are exactly one period to the left and right of my second solution, 12.4915. If I subtract 13, I'll get negative 0.5085. And if I add 13, I'll get 25.4915. And you can see here on our graph that negative 4.4915 is right here. Negative 0.5085 right here. Here were my first two solutions. And 21.5084 and 25.4915. So taking my very first solution here at 8.5084 and jumping one period forward gives me the 21.5084, and jumping one period back gives me the negative 4.49. If I take my second initial solution here at 12.4915, jump one period forward, I get 25.4915, and one period back gives me negative 0.5085. And that's how we solve our sinusoid numerically.